You just got what? 2 more days, right? 2 more days in the exam.
Yeah.
Okay, let's start with the Java, and then we'll move on to Dbms. So we were here on 162. So use of map and hash map. Maps are perfect to use for key value association mapping, such as dictionaries. It is used when we need fast lookups. The maps are used to perform lookups by keys, and when someone wants to retrieve and update elements by keys. A map of zip codes and cities, errors and their descriptions, etc. The HashMap class of Java Collections framework provides the functionality of hash table data structure. It stores elements in key value pairs, and key are unique identifiers used to associate each value on a map. HashMap class implements in map interface. It is non-synchronized. The advantage of hash table is the time of for basic operations like get and put remains constant irrespective of the size of the hash map. Okay, so it stores elements in key value pairs. Keys are unique identifiers, non-synchronized, implements map interface. Advantage is time for basic operation like get and put remains constant. Okay, moving on. List interface. List interface extends collection interface, and hence it comprises of the list methods available in the collection interface. It is used to manage the ordered collection of objects. List preserves the insertion order and allows duplicate values to be stored. Elements can be accessed by referring to their position in the list with zero-based index. This interface comprises of different methods that enable easy manipulation of element based on element index. Various methods defined by list interface are add all, get, index of iterator. So list interface extends the collection interface. It has all the methods of collection interface, manages ordered collection of the objects, preserves insertion order, allows duplicates. Elements can be accessed by referring to their position because it's index based, and interface comprises different methods. They enable easy manipulation of elements, and different methods are add all, get, index of iterator. It's implemented by vector and array list and linked list classes. Okay, I may missed one slide. Okay, so what's the use of list? Did we miss this? Use of list. Sumaya, you have added this?
Yes, I did this.
I think we have to also add the use of this, right?
Yeah.
Yeah. Could you add that tomorrow?
Yeah.
Okay. Just give me 1 second. Just getting a call. Okay. Can you hear me?
Yes.
Um, yeah. So example is this list example. We create this class, and then we instantiate array list. Oh shit! Yeah, one second. This message keeps coming in. Okay. So yeah, we instantiate this array list class, and then we create an object called list, and then we use the add method to keep adding these strings, and then we loop through, I believe, to print all of these elements. I believe it's going to be like an array of strings where each of these items will be added in that list, and then we're printing out each item. Okay. Let's move on. Oh wait, we didn't. Okay, we did color. Okay. JavaFX and its features. So JavaFX is a library used to develop desktop applications as well as rich internet applications. Um, Application built in JavaFX can run on multiple platforms, including web, mobile, and desktops. JavaFX is intended to replace Swing in Java applications as GUI framework. However, it provides more functionalities than Swing. Like Swing, JavaFX also provides its own components, doesn't depend on the operating system. It is lightweight and hardware accelerated. It supports various operating systems, including Windows, Linux, and Mac OS. Web pages can be embedded with JavaFX application. JavaFX contains built-in components which are not dependent on operating system. JavaFX code can be embedded with CSS to improve style of the application. Okay, so I used to develop desktop application. Let's just keep things bold. So it's a Java library used to develop desktop application, Java library, as well as rich internet applications. Applications built in JavaFX FX can run on multiple platforms, including web, mobile, and desktop. Run on multiple platforms. Intended to replace Swing. However, it provides more functionalities than Swing. Like Swing, JavaFX provides its own components and doesn't depend upon operating system. Lightweight and hardware accelerated. Supports various systems: Windows, Linux, and Mac OS. And web pages can be embedded. Web pages can be embedded with JavaFX application. Contains built-in components. Again, they're saying it, we already said that here. Okay, not dependent. Why they're repeating it? It's a repetition. Just said that on the top. Provides its own component, doesn't depend on operating system. Same thing here. JavaFX code can be embedded with CSS. Code can be embedded with CSS to improve style. So it's a Java library used to develop desktop application and rich internet applications built in JavaFX can run on multiple platforms, including web, mobile, and desktops. Intended to replace Swing, provides more functionalities than Swing, provides its own component, doesn't depend on operating system. It's lightweight and hardware accelerated, supports various operating systems, Web pages can be embedded with Java FX application. Code can be embedded with CSS to improve style. Okay, user interface components of Java UI. So GUI of every desktop application mainly considers the UI elements. The UI elements are the one which are actually shown to the user for interaction or information exchange. The layout defines the organization of the UI elements. Behavior is the reaction of the UI element when some event occurs on it. So basically, GUI, graphical user interface of every desktop application, is kind of divided into three parts. One is the UI elements, which is the elements shown to the user, which the user interacts with. Layout is the organization of that UI elements in a certain layout on the screen. And the behavior, what's going to happen if the user interacts with those elements. Now, talking about the UI components, the package Java fx.scene.control provides all the necessary classes for the UI components like button, label, etc. Every class represents a specific UI control and defines some methods for styling. Let's see what those are. So we have label. Label is the component that is used to define simple text on the screen. Uh, Typically, label is placed with a node it describes. Button is a component that controls the function of the application. Button class is used to create a labeled button. Radio button is used to provide various options to the user. User can only choose among among one option among all. A radio button is either selected or deselected. Checkbox is used to get kind of information from the user which contains various choices. User mark the check boxes either on true or false. Text field is basically used to get the input from the user in form of text. Java FX scene control text field represents text field. Password field is used to get the user passwords. When whatever is typed in the password field is not shown on the screen to anyone. Hyperlinks are used to refer any of the web page through application. It is represented by class java fx.scene.control.hyperlink. Slider is used to provide a pane of option to the user in a graphical form where user needs to move a slider over the range of values to select one of them. Progress bar is used to show the work progress to the user. It is represented by the class Java FX Scene Control Progress Bar. Instead of showing the analog progress bar to the user, it shows the digital progress to the user so that user may not know the amount of work done in percentage. Java FX scroll bar is used to provide scroll bar to the user so that the user can scroll down the application pages. Java FX provides a menu class to implement menus. Okay, and that's about it. In Java FX, layout defines the way in which components are seen on the stage. We can skip this. Okay, event handling. So in Java FX application, event is generated when the user interacts with the application nodes. Event handling is the mechanism that controls the event and decides what should happen even if an event occurs. JavaFX provides Java FX event package for basic framework of FX events. Event class works as the base class of Java FX events. Each event is associated with source. A source is an object that generates an event and sends it to one or more listeners. Target, once the listeners have received this event, they process the event and then returns. A target can be window, scene, and a node. Type of the occurred event, example action event, buttons pressed, mouse event, mouse activity, key event, keystroke has occurred. In Java FX application, event is generated when the user interacts with the application nodes. Event handling is the mechanism that controls the event and decides what should happen if an event occurs. Java provides a Java FX event package for basic framework of FX events. Okay, so associated with source, source is an object that generates an event and sends it to one or more listeners. Target, Once listener receives this event, they process the event and then return. A target can be the Windows scene and node and type of the occurred event. Example: action event, mouse event, and key event. Okay. Okay. Uh, when a source generates an event, the Java FX application goes through four stages for the event handling. First is target selection. When any user interacts with the UI controls, then the action occurs. At that moment, the system decides which node gets the focus. Route construction. When an event is generated, the default initial route of the event is determined by the construction of an event dispatch chain. It is the path from the state to the source node. Event capturing. Then the root node of the application dispatches the event. This event travels to all the nodes in the dispatch chain. If any of these nodes has a filter registered for the general generated event, it will be executed. Event bubbling. In the event bubbling phase, the event is traveled from the target node to the stage node. If any node in the event dispatch chain has a handler registered for the generated event, it will be executed. Okay, so event handling extends frame, implements action listener, text field. Okay, so you declare a variable called text field of type text field. We are importing event packages and AWT. Then we create a event handling function where we instantiate the text field class and hold it against the text field. Then text field, we are setting the bounds like 60, 50, 170, 20. We are putting the text inside of the button. Again, we are setting the bound for that, for the text field and for the button. And then we adding the event on that event listener on this button, event handling, adding the button, adding the text field to the screen, setting the layout, setting visible to true. And then here, oops, action is performed using this function where it's going to set the text to hello world. So when the user clicks on the show button, uh, the event listener will be called, action perform function will be called, and is going to set the text to hello world, which was initially empty. And then here we're just instantiating this class event handling. Okay, what is JDBC? uh, Java database connectivity. So JDBC API used to provide database connectivity between Java application and various databases. It defines how to access RDBMS through standard interface and classes. JDBC API helps us to write Java application that can access tabular data. This allows the Java application to access various types of databases like Oracle, MS Access, Sybase, MySQL, SQL Server. It offers platform-independent interface between Java application and the RDBMS and allows the application to execute SQL statements. Various tasks are associated with the database usage, such as establishing a connection, query creations, query execution, and viewing and modifying the resulting records. Provides two packages, java.sql and javax.sql. Okay, once recapping this, it's used to provide database connectivity between Java application and various databases, defines how to access RDBMS through standard interfaces and classes, helps us to write Java applications, allows Java applications to access various types of databases, offers the platform independent interface, Various tasks are associated with the database usage, such as establishing a connection, query creation, query execution. Uh, Provides two packages, java.sql and javax.sql. Advantages: provide existing enterprise data. Business can continue to use their installed databases and access information even if sorted on different database systems. Simplified enterprise development. Combination of the Java API and JDBC API makes application development easy and cost effective. Zero configuration on the network computers. No configuration is required on the client side. Centralizes software maintenance. Driver is written in the Java. So all the information needed to make a connection is completely defined by the JDBC URL. Data source object is registered with the Java naming directory interface, naming service. Full access to metadata. The underlying facility and capabilities of a specific database connection need to be understood. It provides metadata access, enables development of sophisticated applications. No installation. So it's pure JDBC technology based driver, does not require special installation. And it includes a way to identify and connect to a data source using a data source object. This makes code even more portable and easier to maintain. Okay, JDBC driver manager class and its use. It's a concrete Java class, provides an interface between user and the drivers. Uh, JDBC driver can create database connections, but generally driver manager is used to get the connection. JDBC driver manager provides elementary services to maintain JDBC drivers and define an object that connects the application to the driver. The driver manager manages the various drivers running on the application. It tracks the available drivers and appropriately chooses the one which connects the application with the database. The get connection method is the most commonly used method of class to establish database connection. The class.forName method is used to load the driver. The class.forName com.mysql cj jdbc.driver. It's an example. So the register driver method of driver manager class registers the given driver in the driver manager's list. If the driver is null, it returns null pointer exception. Public class driver manager examples: public static void main throws SQL exception, instantiating the com.mysql.jdbc.driver. Then we are registering the driver using the register driver function. Then we are printing it that the driver registered successfully. Okay. Talk about JDBC batch processing. Instead of executing a single query, we can execute batch group of queries. It makes performance fast. So basically talking about batching the query, like grouping the query together rather than executing them one by one, which could be expensive, group them together using batch processing. It is because one sends multiple SQL statement of SQL at once in the database, the communication overhead is reduced significantly as one is not communicating with the database frequently, which in turn results to fast performance. The java.sql statement and java.sql prepared statement interfaces provide methods for batch processing. The required methods of batch processing are given below. Add batch, method of callable statement, prepared statement, and statement is used to single statement to a batch. Execute batch begins execution of the group together statement. Supports batch update. If the target database facilitates the batch update processing, then the method returns true. Clear batch removes all the statements that one has added using add batch method. Write a program to explain JDBC batch processing, importing the SQL, fetch, create the class called fetch records, and then your main function throws exception. We call the For name method, we pass oracle.jdbc.driver.oracle driver. Then we um, call the function called get connection, and we pass all of the details like the host, password, and username. We set auto commit to false. Then we create the statement and hold it in the statement, and then using the statement dot add batch, we are kind of adding the query, the first query, insert into user 420 values into that batch, and then we adding a second query in the batch, and then finally using execute batch is going to execute both the queries together rather than executing them one by one. Then we commit it, and then we close the connection. Okay, finished. So now we'll go to uh, third normal form. We did this yesterday. Higher normal form. I'm gonna skip this 4NF and 5NF. Directly on the MySQL. So Maya, can you read this? 1 second. See if yeah.
What is SQL? SQL is a standard query language for accessing and manipulating databases.
Wait a minute. Okay. The full form is structured query language, but in the definition, it's called standard query language. Okay, fine.
SQL is called a non procedural language as it specifies what is to be done rather than how it is to be done. Since SQL is a higher level query language, it is closer to a language like English. Therefore, it is very user friendly.
Okay.
SQL can execute queries against a database, create new databases, new tables, perform CRUD on databases, create stored procedures, views in a database, set permissions on tables, procedures, and views. Disadvantages of SQL are complex interface for users, cost for programmers, and partial user control.
Okay, so SQL is a structured query language for accessing and manipulating databases. It's called a non-procedural language. 1 second. Structured query language for accessing and manipulating. It's called a non-procedure language because it just specifies what to be done rather than how it is done. It's a higher level query language. Closer to the language like English, it's user friendly. Execute queries against the database, create new database. I think this is easy. Execute query against database, create new database, new tables, perform CRUD, create stored procedures and views, set permissions on tables, procedures, and views. Disadvantage is complex interface for users. Cost for programmers and partial users. इन लोग कोई भरोसा नहीं, कुछ भी कहीं से भी पूछ सकते हैं. डिसएडवांटेज पूछ दें एसक्यूएल क्वेरी का. Okay, so let's do a recap again. SQL is a structured query language for accessing and manipulating database. It's called non-procedural language because it just specifies what to be done rather than how to do it. It's a higher level query language. It's closer to the language like English, therefore it's user friendly. Okay, so it's a standard query language for accessing, manipulating database. It's a non-procedure language. It only specifies what to be done instead of how to do it. It's a higher level query language. It's close to English language, therefore it's user friendly. It can create database, it can manipulate database, it can perform CRUD operations, it can create tables, it can give the permissions for the stored procedures, for the views. It can create stored procedures and views. The disadvantage of SQL is that the first is the cost, and second is the complex structure. So execute the queries against the database, create new database, new tables, perform CRUD, create stored procedures views, set permissions to the table. Disadvantage of complex interface, uses cost for programmers and partial users. So structured query language for accessing and manipulating database, non-procedural language specifies what to be done and how to instead of how it is done, and higher query language close to English. Okay, so let's do a recap. So Sumaya, give me 1 point on the SQL. What is SQL?
SQL can be used to create databases and tables
Okay, okay,
and run queries on them.
okay, and it is a um, standard query language. What is it used for? It's used for creating and manipulating databases. Give me one of its disadvantages.
Um, Complex structure, cost for
Yeah.
programmers.
Yes, correct. And it's a high level query language. Why is it very easy to use?
Because it is similar to English.
Yeah,
It's
English
user
language.
friendly.
The words are like select is like the word itself is in English, so we can understand select from, where. So all those are English like language, so it's easy to understand. Okay, right. Structured query language access manipulating database. Non-procedural language just specifies what to be done rather than how it is done. High-level query language closer to English language, so it's user-friendly. Can execute queries against database, create new database, new tables, perform CRUD on the database, create stored procedures, views in the database, set permissions on tables, procedures, and views. Disadvantages of SQL are complex interface for users, cost for programmers, and partial user control. On ETL, data definition language. Why this is blue? Did it come in examination, or why is it blue? Oh, create one came in. That's why. Okay. Okay. So data definition language is used to do what? Set of commands used to create and modify the schema objects such as tables, indexes, and views. Defines a set of commands. Data definition language set of commands used in the creation and modification of schema objects. Used to create. Make it shorter. Create and modify schema objects. Tables, index, and views. Okay. These commands provide the ability to create, alter, and drop these objects. So create. I think in the exam they've asked, please write down how to create a table. You have to write the command for that. Explain create table command. So create table command is used to create a new table on a or a new database. Syntax: create table, table name. You put column name. You put data type, column width, and the constraint. Okay. So is this column width? This is data type, right? Column with constraint. Well, constraint probably goes on after this. We haven't put any constraints here, I guess. This is just column width, like how big it is. So create table, that's the keyword, and then the name of the table, then the name of the column, in this case std name, student name, and then data type, which is varchar, and then column width is 20. And probably when we are using primary key, we'll use not null or something. That must be the constraint. Okay, why do we not have primary key, or I don't understand. Branch, varchar, college, age, number, telephone, address. Okay, modify the schema object. Right. So do you want to read this before we recap this?
Yes.
Okay, go on.
DDL defines a set of commands used to create and modify schema objects such as tables, indexes, views, etc. These commands provide the ability to create, alter, and drop these objects.
Mhm.
Create is used to create a new table or a new database. Syntax is create table, table name, column name, data type, column width, and constraints. Like student name, Farkar 20.
Okay.
Or we could have student ID with the primary key.
That's what I'm
Student
saying.
ID in
Why we don't have
primary
that?
key.
Uh, let's see. Of create table command in SQL. Yeah, they should have put not null. I don't know why I'm not putting not null. Yeah, like that. That's what I'm talking about. That is your constraint. So we should put that, in my opinion. I think this is a better one. We should use this one instead. Just paste the screenshot. Okay, so now it looks much better. ID, that's your table, sorry, column name, attribute name. Then you have data type, and here you don't have the column width, but then this is constraint, not null. Similarly, you have the column name, you have data type, you have column width, and then the constraint. Okay, so let's try to recap this. So a data definition language is basically a set of commands that is used to create and modify the schema objects, um, and you can use it to create a table, insert, and you can alter it as well. Oops, this is being shown. We have to hide it. Yeah, I can do that. No, that. Okay, better. Okay, so the syntax is create underscore table, and then the table name, and then inside that you have the column name, the data type, column width, and the constraints. Example is create underscore table, table name may be customers, and inside of that you have ID, which is the column name. Then you have uh, the data type, which is int. We skip the column width, and then just put not null, which will be constraint. Okay. Times. Okay, so yes. So May, what is DDL?
And DDL is used to create, modify, or drop tables in the database.
Mm-hmm. And give me the syntax for creating table.
Create table, table name,
Mm-hmm.
and then the list of columns, column name, data type, uh, column width, and
Yeah.
constraint.
Cool. And it's round bracket after this, and this not underscore which I said. There's no underscore here. It's round bracket. Okay, cool. Hey, what's this at the end? Primary key ID. It's set like that, I guess. So although you're defining it here, but you also have to set primary key ID here. Okay. So then we do the alter command, alter table and space table name, and then you can add, modify, add constraints, drop, enable, disable. Leave all of that because we anyways practicing that. Okay. So transactions with examples. A transaction is a basic unit of work on a database management system. It defines the data processing on the database. For example, some of the transactions at bank may be withdrawal or deposit of money, transfer of money, and A's account to B's account, etc. A transaction would involve manipulation of one or more data values in a database. Thus, it may require reading and writing of database value. For example, the withdrawal transaction can be pseudocode as assume that we are doing this transaction for a person whose account number is X. Transaction withdrawal, withdrawal amount, begin transaction if X exists, so which means the account number exists. Then read X dot balance. If X dot balance is greater than withdrawal amount, then subtract withdrawal amount, write the X balance, and then commit. So when we're writing the queries, we have to commit, and we can always roll back to that. So we're committing here. So we're saving the our work there. Else display transaction cannot be processed. Else display uh, account X does not exist. So it's just a pseudo code, not actual code. To give an example of a transaction in the bank. So transaction is basically a basic unit of work on a database management system. It defines data processing on the database. Okay, fine. So may I want to read?
Yeah. A transaction is the basic unit of work on a database management system. It defines
Mm.
the data processing on the database.
Yeah.
For example, some of the transactions at a bank may be withdrawal or deposit of money, transfer of money from A's account to B's account. A transaction would involve manipulation of one or more data values in a database. Thus, it may require reading and writing of database values. For example, the withdrawal transactions can be written in pseudocode as begin transaction if x exists, then read x dot balance. If x dot balance is more than withdrawal amount, then subtract withdrawal amount. Write x dot balance. Commit, else display transaction cannot be processed. Or if x does not exist, display account x does not exist.
Right. So transaction is a basic unit of work for database management system. Uh, it defines data processing on the database. We are taking an example that some of the transactions at the bank may be withdrawal or deposit and transfer of money from one person's account. So we just give an example of a bank here. We talk about what type of transactions are there. There are withdrawals, there are deposit, there are money transfers. We talk about that. Then we give another example saying that a transaction would involve manipulation of one of the data values in database. So we will say that if it has to occur in the bank, how is it going to occur in in their database? So it will involve manipulation of one or more data values in the database. Thus, it may require reading, writing of the database value. So, so if the user transacts, then how will the queries be executed? So there'll be reading and writing of the database value. For example, this pseudocode. So assuming that we are doing transaction for person X, sorry, for a person whose account number is X. So we say transaction withdrawal amount. We begin the transaction. If X exists, then read X dot balance. If X dot balance is greater than the withdrawal amount, then subtract uh, withdrawal amount, write the balance, and then commit. Else, display transaction cannot be processed. Else, display account X does not exist, and we end the transactions. We have to begin and end, and before beginning and ending, you have to put transaction withdrawal. Okay, so let's do a recap. So, what are transactions in database management system? Sumaya?
A transaction is a basic unit of work and it defines the data processing in the database.
Okay. Give me an example.
Uh, Withdrawal of money from an account
Okay.
is an
What
example.
happens in the bank? Or what type of transactions happens in the bank?
Um, Withdrawal, deposit,
Mm-hmm. And what happens between one account to other?
transfer.
Yes. Yes. So, how does that work in their database? Let's say a transaction happens. So, what happens to their database when that happens? What type of executions would happen?
Money would be subtracted from one account and added to another account
Right. So,
during a transfer transaction.
in terms of data management terms, what are those things called? Read and write.
Data would be read and written.
Correct. Correct. Okay. Now I'm going to hide this one and see how much we can recall this. So let me try and then you can also try. So let's say, for example, there's a person whose account number is X. So we first write the first heading, which is bank transaction or whatever that name was. And in the bracket, we put the withdrawal amount. And then we say begin transaction, semicolon. And at the end, we do end transaction. And then we say if uh, the account X exists, then if the balance dot x dot balance is greater than the withdrawal amount, sorry, yeah, if it is less than the withdrawal amount, no, it has to be greater, not less. Yeah, it has to be greater. So if the account x dot balance is greater than the withdrawal amount, then we have to withdraw the amount, which is basically subtract the amount from the account, and then also write it, and then commit it, and then else we will print a message to the user saying that the amount does not exist. Else we'll say the account number doesn't exist, and then we end transaction. I'd like you to take a look at it, read it once, and then try saying it without looking at this guy.
Okay, I think I remembered.
Okay, cool. Go ahead.
Uh, Begin transaction.
Mm-hmm.
Uh, if X account exists,
Mm-hmm.
then read X,
Mm-hmm.
subtract withdrawal amount from X, write to X.
No, I think we have
Um,
to first check whether the amount is greater than the.
oh
Uh,
yes,
yeah.
if X dot balance is greater than a withdrawal amount, then subtract the withdrawal amount from X and write to X. Else,
No, commit also. Then we go to
okay,
else.
commit,
Hmm.
and then else print the transaction failed.
Hmm.
And then there's a second else if the account does not exist, then print the account doesn't exist.
Right. And at the end,
And
what do
then
you have to
end
write?
transaction.
Correct. You have to write one more statement on top, which is transaction withdrawal, and then bracket, in the bracket you have to put the withdrawal amount before beginning the transaction.
Yeah.
If X exists, then read X dot balance. If X dot balance greater than, then subtract withdrawal amount, write X dot balance, which means whatever the balance is left, we just whatever the value of that balance is, we're putting that in the database, so that next time somebody comes in and tries to withdraw again, we have the new balance and not the old one. That's why writing is important here. Else display transaction or process, else display account does not exist, end transaction. Cool. Concurrent transaction, simultaneous transaction. Uh, in a multi-user system, multiple users can access and use the same database at one time, which is known as concurrent transaction in database. Multiple users can access and use the same database at one time. Okay. It means that the same database is executed simultaneously on a multi-user system by different users. The DBMS must ensure that two or more transactions do not get into each other's way. That is, the transaction of one user should not affect the transaction of the other. Even the transaction issued by the same user should not get into the way of its own. Multi-user system, multiple users can access and use the same database at one time, which is known as concurrent transaction. It means that same database is executed simultaneously on multi-user system by different users. Okay. Database must ensure that two or more transactions do not get in each other's way. Transactions of one user should not affect the other. Even the transaction issued by the same user should not get into the way of its own. Same user should not get into the way of its own. Okay, so in a multi-user system, multiple users can access and use the same database at one time, which is known as concurrent transaction. It means the same database is executed simultaneously on a multi-user system by different users. So the key idea over here is that when we're dealing with database queries which are executed, there could be multiple users, like the different forms that are being submitted online. They are interacting with different things like input fields where they are entering their data. So there are multiple users, and when they are submitting those data, basically multiple queries are being executed simultaneously at the same time. So we don't want that. um like, let's say that one user is writing some information for a particular record while the other is reading it. They shouldn't be getting into each other's way, and one user should not even get into its own way, uh, because if they did that, then there could be a lot of issues in the transaction. For example, one second. For example, one has read the value of a balance is 10,000, and the other one comes and reads the value as 10,000. The other one subtracts, let's say, 5,000 from that, and the first one now then adds 3,000. Okay, so for each one of them, for first one, according to him it's 5,000, and for the other one it's actually 13,000. So there's a clash there because it's happening at the same time. And I think that is why locking and stuff is used, so that one transaction, one when it completes, then only it'll allow the lock to be released, and somebody else will pick it up. So again, a recap on this one. In multi-user system, multiple users can access and use the same database at one time, which is known as concurrent transaction. It means same database is executed simultaneously on a multi-user system by different users. So have you heard of passive voice in English language? You know what passive voice is?
Yes.
Yeah. So if a statement is written like I am doing something, so that's then active voice, and something is done by me, that's passive. So that's exactly what is happening in this two lines. First we are going active voice, the multiple users can do this, and then we are going passive voice, that database is executed by different users. So just writing in that way. Okay, do you want to read this before we recap?
No, I think I
Okay,
remember most of it.
tell me what are concurrent transactions in database management system.
In a multi-user system, multiple users can access and run transactions on a database at the same time.
Mm-hmm.
So those are called concurrent transactions.
Mm-hmm. What's the passive
Um,
voice?
the database is being um, modified by multiple users.
Simultaneously, so being
Yeah.
executed by multiple users simultaneously. Okay, so what is it that databases should ensure so that the problem doesn't occur? What are the two
The
things?
database should ensure that multiple transactions don't get in the way of each other.
So one
Even
user should
transact,
not get into the way of another user in the
yeah,
transaction, right? And the second point?
and even the transactions run by the same user should not get in the way of each other.
No, not each other, on his own way. Each other is already done in the first part. Okay, so even transaction issued by the same user should not get into the way of its own. खुद के ही वे में ना आ जाए वो,
Hmm.
मतलब खुद ही वो रिक्वेस्ट भेज रहा है और फिर सेकंड रिक्वेस्ट भी खुद ही भेज रहा है वो। यहाँ पे दो अलग अलग यूजर भेज रहे हैं, दो अलग अलग रिक्वेस्ट। यहाँ पे सेम यूजर, एक रिक्वेस्ट उसने भेजा, फिर से एक और रिक्वेस्ट भेजा, तो इट्स गेटिंग इट्स ओन वे। Okay. Yeah, so in a multi-user system, multiple users can access and use the same database at one time, which is known as concurrent transaction in the database. It means same database is executed simultaneously on a multi-user system by passive voice कर दिया पर by different users. DBMS must ensure that two or more transactions do not get into each other's way. That is, the transaction of one user should not affect the transaction of the other, and even the transaction issued by the same user should not get into the way of its own. So problem. So this is the problem I talked about. Let's say there are two users. One is reading X, it read X is 10,000. Second read X is 10,000. So at this point, no issues. Both have read 10,000. First user subtracts 5,000, so current value becomes 5,000. Second user adds 3,000, but because he read it as 10,000, and for him it is not, at this point it should have been 5,000, but for him it's still 10,000 because he read at that point of time. So he will add 3 more, so it becomes 13. Then the first user writes X, so it becomes 5,000. And then writes means like saving his work basically. So he saves, it becomes 5,000. He saves his work, it becomes 13,000. So in the actual scenario, it should have ideally been, uh, he's subtracting 5, so that is left 5, and then he added 3,000. That should have been 8,000, right? That should have been actual, but it didn't happen because of simultaneous requests, concurrent transactions. So the problem occurs when two different database transactions perform read-write operation on the same database items in an interleaved manner. So this is a good word to remember to probably gain higher marks. Interleaved manner, which is concurrent execution. You know, the book pages, uh, in when you were a child, you must have purchased books where one page was blank and the other page was ruled. For diagrams, you had the blank one, and for writing, you had the ruled one. It's the same book.
Yeah.
So you can call it like these pages were interleaved between each other. Okay, so they were concurrent but interleaved. So these guys are interleaved. You know, this comes, then this comes. These are two different users, but they're interleaved one after the other. Okay, so that's the interleaved means. Okay, so interleaved manner that makes the values of the items incorrect, hence making the database inconsistent. So basically, just explaining the previous thing in a different way, and then just explaining this problem. So one is lost updates. Suppose two transactions T3 and T4 are concurrent and they happen to interleave in following way. Assume initial value of X is 1,000, sorry, 10,000. After the execution of both transactions, the value X is 13,000, while semantically correct value should have been 8,000, like we just discussed. The problem occurred as the update made by T3 has been overwritten by T4. Whatever update he made is overwritten by this guy. Thus, one of the two updates have been lost, and we call this as a lost update has occurred. Okay, so this is one of the problems, a lost update. Another problem is the unrepeatable read. Suppose T7 reads X, so he's reading X, he gets the value as 2000 during its execution. A problem of inconsistent value maker if between two read operations, like he read it once and he's reading again, but in between his reading there was a time gap where somebody else came and updated the value to 3000. So now he earlier he read 2000, now he's reading 3000. So now it's the problem, unrepeatable reads. So yeah, so suppose T7 reads X twice during its execution. Problem of inconsistent values. So inconsistent reads. Earlier it was 2000, then it's 3000. Because between two read operation of this guy, another transaction T8 modifies the value of the same data. So there's a problem there. So we had what? We had lost update where one of the two updates were lost because it was overridden by the other one. And then we have unrepeatable reads because while one of the user was reading it, between the reads of his transaction, it was updated by another user, same data. Then you have dirty reads. Dirty reads means the the dirty read problem occurs when transaction updates an item. and somehow transaction fails. Okay, you try to update it. Okay, the updated item is accessed by another transaction. There comes the read write conflict between both transaction. Okay, so I guess the initial value would have been 200. That's what it's saying over here. The value of x was 2000. Sorry, 200. This guy came, T9. He said, okay, let's update it to 500. Okay. He tried to update it. Another user came, he read it, he got it 500. He started working on it. But this update failed. So there was a rollback. So it was put back to 200. But this guy has got 500, he's working on it, and then he's going to go and update it later on. But actually, this update didn't go through. So this another user is reading it incorrectly. So that's dirty read. Dirty read is when the update fails by one of the users, and while the update was getting failed or committed, somebody else read it. Then you have inconsistent analysis. This problem occurs when more than one data items are being used for analysis, while another transaction has modified some of those values and some are yet to be modified. Thus, an analysis transaction reads value from the inconsistent state of the database that results in inconsistent analysis. Understood, right? I'll probably revise this again tomorrow, but I hope you've got it. It's not too difficult.
What was the last one? There's no example for it.
I haven't put any example, but it's just saying that when you're analyzing one of the records, some of the records basically, and another transaction has modified those values, and some are yet to be modified. So the process is going on, and an analysis transaction reads those values from the inconsistent state of the database. So while some transactions are going on, while some modification is happening, some other guys are reading it. So that's inconsistent analysis is because you're not really reading the correct values because they're still under the process of modification. Maybe you can get that from the book and you can paste it here. Okay.
Okay.
Yeah. Moving on. Talking. Just 1 second. Yes. How much more is left? Okay, let's take a break. I think let's catch at 6:30, shall we?
Okay.
I'll keep this on. We'll meet at 6:30. Sumaya, you're back.
Yes.
Okay. See. Share screen. Okay. How much more is left? It's a lot to study. Just too much to study. Okay, so we're going to do locking now. So, which is what I spoke about, the problem of the concurrent transactions. So, we have to lock. So, locking is a technique used to lock or restrict some data in a database so that only one database user session may update that particular data. This prevents two or more database users from updating the same exact piece of data at the same exact time. A lock can be placed by a transaction on a shared resource that it desires to use. Um, when this is done, the data item is available for the exclusive use of that transaction. The other transactions are locked out of that data item. When a transaction that has logged a data item does not desire to use it anymore, it should unlock the data item so that other transactions can use it. Okay, so who locks the transaction? Sorry, who locks the data item? It's a transaction that locks it. So just to keep things to remember. If a transaction tries to lock a data item already locked by some other transaction, it cannot do so and waits for the data item to be unlocked. So all lock requests are made to the concurrent control manager. Transactions proceed only once the lock request is granted. So all of the lock requests will be made to the concurrency control manager, and transaction can proceed once the lock request is granted. So they cannot proceed. Like for example, they request there is a data item that they're trying to manipulate. What they're going to do is, let's say the first transaction will send a request to concurrent manager saying that okay, I want to make an update to that particular data item. So concurrent manager is going to grant that request, and that transaction will lock that data item. Another request comes in, another transaction request comes in to concurrence manager who wants to make changes to that particular data item again simultaneously, but you can't do that. So concurrent control manager is not going to release, not going to fulfill that request. It'll say we have to wait because there's another transaction which already going ahead and making changes to that data item. So you have to wait until it releases that lock. So once the previous one releases the lock, then the other transaction which wants to go ahead and make a manipulation on that data item will grant the access of the lock. It'll go ahead and attain that lock request, perform the manipulation, and then release the lock request so that somebody else can come in. So that's how the process goes on. So assume two people who go to electronic kiosk. So it's a real world scenario. Two people go to electronic kiosk at the same time to buy a movie ticket for the same movie. Let's say on Book My Show, or or the electronic kiosk. And however, there's only one seat left in for the movie show in that particular theater. Without concurrency control in database management system, it is possible that both moviegoers will end up purchasing a ticket. However, concurrency control manager method does not allow this to happen. Both moviegoers can still access the information written in the movie seating database, but concurrency control manager will only provide a ticket to the buyer who has completed the transaction first. Okay, so Sumaya, do you want to read this?
Yeah. Locking is a technique used to lock or restrict some data in a database so that only one database user or session may update that particular data. This prevents two or more database users from updating the same exact piece of data at the exact same time. A lock
Yeah.
can be placed by a transaction on a shared resource that it desires to use. When this is done, the data item is available for the exclusive use for that transaction. That is, other transactions are locked out of that data item. When a transaction that has locked a data item does not desire to use it anymore, it should unlock the data item so that other transactions can use it. If a transaction tries to lock a data item already locked by some other transaction, it cannot do so and waits for the data item to be unlocked.
Mhm.
All lock requests are made to the concurrency control manager. Transactions proceed only once the lock request is granted. Example, assume that two people who go to electronic kiosks at the same time to buy a movie ticket for the same movie and the same show time. However, there is only one seat left in for the movie show in that particular theater. Without concurrency control in DBMS, it is possible that both moviegoers will end up purchasing a ticket. However, concurrency control method does not allow this to happen. Both moviegoers can still access information written in the movie seating database, but concurrency control only provides a ticket to the buyer who has completed the transaction first.
What's the pronunciation of concurrency? It's like it's concurrency.
Concurrency.
Yeah. Concurrent, con will be if it's concurrent, then you can use it. But if it's concurrency, then you use concurrency, not concurrency. Let's try that. Pronunciation. Oh, this is also concurrent.
Concurrent.
Okay. Both are concurrent. It's not con. Cool. So, of course, it is a little difficult to remember this word by word, but I'm assuming that you've understood it, right?
Yes.
So, can you explain it into your own words with an example? What is locking?
Locking is a technique used to restrict access to some data while some transaction is using it, so
Okay.
that more than one transaction are not doing work on the same data or the same resource at the same time.
Yeah. What else?
After the transaction is finished with the resource, then it unlocks it so that other transactions can access it.
Right. So that's the standard locking protocol. Now, tell me what happens in with relation to how the requests are made to the concurrency control manager. How does that get handled?
Locking requests are made to the concurrency control manager,
Okay. When
and
does it grant it?
it's granted to a transaction if uh, there is no lock placed on the item.
Mm-hmm.
And if there is a lock placed, then the transaction has to wait until it is unlocked.
Right. Correct. Okay. Fine. And once the transaction is complete on a particular data item, what does that transaction do to the lock?
It unlocks the data item.
It releases that lock, right?
Yeah.
Okay. Give me an example in a real world scenario of how locking system is useful.
If two people are trying to buy a movie ticket at the same time,
Mm-hmm.
uh, then uh,
If it was not in place, if the concurrency was not in place, what will happen?
if the if
Concurrency
concurrency
manager.
was not in place, then uh, they would both be allowed to buy a ticket, even though there is only one ticket left.
Okay.
And if there is concurrency management, then
Mhm.
only the user who completes his transaction first will get to buy the ticket, and it will the other one will not be allowed to buy it.
Perfect. So I think since you've understood it, it's very easy for you to do and write in the exam. You don't really have to worry about remembering it word by word. But yeah, I'll also give a recap. So locking is a protocol in which a particular data item is only allowed a transaction by only allowed to be manipulated by one transaction at a time. Another transaction cannot manipulate it until and unless the first transaction is complete. So how this works is that in relation to the concurrency control manager is that, for example, if there's a transaction that makes a request to the concurrency control manager that it wants to go ahead and make change or work on a data item, if there are no other transactions that are working on it, then the request will be granted. And once the transaction completes, it'll release that lock. If while the transaction is being completed, another transaction makes a request to the concurrency control manager and says that I want to work on this, please, I want to request for a lock, it request will not be granted until unless the first transaction completes the request and releases the lock on that. Example in the real world scenario is two moviegoers are going to purchase a ticket from an electronic kiosk. If the concurrency control manager was not in place, then they will end up buying the tickets, two tickets for if there was just one single seat available. However, if the concurrency control manager is in place, then the ticket buyer which completes the transaction first will only be allowed to purchase the ticket, although they both can access the database and look at the seats that are available. Cool. Let's move on. Locking is a technique to lock restrict some of the data in database, so only one database or user may update the particular data. This prevents two or more database from updating the same exact piece of data at the same time. Lock can be placed on transaction on shared resources that are desired to use. When this is done, data item is available for exclusive use of that transaction. Other transaction is locked out of that data item. When a transaction that has locked a data item does not desire to use it anymore, it should unlock the data so that other transactions can use it. If a transaction tries to lock a data item already locked by some other transaction, it cannot do so and waits for the data item to be unlocked. And that's it. Okay, so how locking solves the concurrent transaction problem with example. Um, so we'll take a look at this example basically. Mm, Lock-based protocols in Dbms is a mechanism in which the transaction cannot read or write until acquire appropriate lock. Lock-based protocol helps to eliminate concurrency problem in database for simultaneous transactions for locking or isolating a particular transaction to a single user. Types of locks are binary lock and multiple locks. So the top part is very similar to what we discussed. I mean, we don't really have to write this. We can explain into our own words, which is fine. But yeah, for types of locks, we can describe binary lock. This locking mechanism has two states for the data item, locked or unlocked. In the given example, when you obtain all the locks at the beginning of the transaction and release them at the end, ensures that transactions are executed with no concurrency related problem. So what's happening here? So here we are going to obtain all the locks at the beginning. So let's see how that works. So we have lock X placed by T1, lock Y. Um, okay. So X is locked, Y is locked. Then T1 is reading X, subtracting 100. Is there a column mismatch here? No, right? Yeah, no. Okay. Subtract 100, write X, lock X by T1, denied as T1 holds the lock. Okay, so now T2 is trying to place a lock on this. So T1 went ahead and locked X, locked Y, read X, worked on X, basically written X. At the same time, the T2 is trying to lock X, but is getting denied because T1 is still working on it. So let me put the charge on. My battery is going down. Okay. So at this point, T1 is still working on X while T2 is trying to ask for a lock on this, but it's not going to be able to do that. So because it's still working on it, T1 is working on it. At this point, T2 is going to read Y. Sorry, T1 is going to read Y, work on it, and going to unlock X at this point. Notice that it does not releases lock on the X until it completes all the transaction on each one. It's kind of locked both of them. It's not releasing it until transaction on both is complete in this scenario. Okay, so it's done its work on X. It's done its work on Y. Now it's unlocked X. At the T2 was probably in the queue. It's requesting uh, X to be unlocked, and now X is unlocked. And because X is unlocked, now T2 can work on it and let T1 unlock Y. That's completely fine. So lock Y. Now at this point, it's locking Y, and then this is where the transaction starts for the T2. So looks like uh, when you obtain all the locks at the beginning of the transaction and release them at the end, ensures transaction executed with no concurrency related. That's binary lock. So I think binary lock states that you have to, if you're going to work on two pieces of data, then you have to acquire lock on both of them at the first, and you're not going to release the lock until and unless you have completed transaction on both. So that's exactly what's happening here. T1 acquired lock on both X and Y, did not release, even though it finished working on one of them. It released it once it's finished both the actions. And then similarly go for T2. It acquired lock on X. It didn't start the transaction here. Notice it is not starting the transaction. It is locking Y also. Once it locked both of them, then it's going to start performing operation and finally unlock both of them together. So that's your binary lock. Let's see how is multiple mode. Oh my god, this is another couple more here. Okay, it offers two locks: shared lock and exclusive lock. With shared lock, the data item can be shared between transactions. Let me just make this bold so we remember first. When you obtain lock at the beginning, all locks at the beginning, and release them at the end. Hopefully, we'll remember. Let's go one by one. A shared lock or read-only lock. With the shared lock, the data item can be shared between the transaction. This is because you never have the permission to update the data on the item. So shared lock is basically to do with the reading of the information. So a lock can be shared between multiple transactions only because you're not updating the data, you're only reading it. So because you're only reading it, it's okay to be shared between multiple transactions. That's what shared lock is. And I think the other one, exclusive lock, is like because the data item will be written, this is exclusive and can't be held concurrently on the same data item. Okay, so we'll come to that. We'll continue with this for now. So with shared lock, the data item can be shared between transactions. This is because you will never have the permission to update data on the data item. So in shared lock, you can't update it. For example, consider a case when two transactions are reading the account balance of a person. So let's say there are two counters in a bank, and uh, how would that work actually? That won't work, right? Because they are reading the transaction for the same person. Okay, anyways, let's not go hypothetical. Okay, so consider a case where two transactions are reading the account balance of the same person. Database will let them read by placing a shared lock. However, if the transaction wants to update the account balance, shared lock prevent it until reading process is over. So let's see here. So S, it's represented by S. So you say S underscore lock. So T2 places shared lock on X, shared locks on Y. You can read X, transaction 11 tries to place a shared lock on Y and shared lock on Z. So of course you can place a shared lock. Another transaction can place a shared lock where there's already been locked by another transaction. So the both can place the lock because it's shared lock. They're only reading it. It put the shared lock on Z. It read Y. It read Z. Okay, which is fine. Here, then we have something called X lock X, the exclusive lock request on X. Okay, so first let's read the exclusive lock. With the exclusive lock, a data item can be read as well as written. So both can happen, read and write operations. This is exclusive and can't be held on concurrently on the same data item. So which means uh, more than one transaction cannot put exclusive lock on the same item. Unlike shared lock, where two transactions are able to put the lock on the same item, in exclusive you can't. And the reason for this is because shared lock, uh, you can read, so it's okay, you can't update. But in exclusive, you can update, you can write. That's why only one transaction can place a lock on one item, not the other at the same time. Xlog is requested using log X instruction. Transactions may unlock the data item after finishing the write operation. Okay. For example, when a transaction needs to update account balance of person, you can allow this transaction by placing X lock on it. Therefore, the second transaction wants to read, write. Exclusive lock prevents this operation. Okay, let's see. So till here it was clear. Here till here there were shared locks and two transactions could place the shared lock on the same item, which is Y. But from here the things changes. So now comes the exclusive lock, which is denoted by X. So X lock X, the exclusive lock request on X is denied as T2 hold the read lock. Okay. So if there's already a read lock on a particular data item, then you can't put an exclusive lock on it unless it's released. So that's another clause. Okay, so because T2 is already holding a shared lock on the X, you can't really put the exclusive lock here. That's why it's getting denied. So it is going to wait. Transaction T1. So T1 is trying to put that. It's going to wait. Okay, now read Y. So T2 is reading Y, T2 is displaying. Now at this point, T2 is going to unlock the X. So now X is available. Okay. So X locks Y, X lock Y. Okay. The previous exclusive lock request is granted as X is unlocked. Okay. But the new exclusive lock on Y is not granted as Y is locked by T2. Okay. So what they're saying is that because X was unlocked, it's okay to put an X lock on it, but you can't, which was like waiting in the queue. But when you're trying to put the X lock on Y, which is the exclusive lock on Y, you can't do that because T11 is holding it, holding a read lock on that, which is a shared lock. Okay. Thus T1 waits till both T2 and T11 release the read lock on Y. Okay, so both have placed the lock on the Y and they haven't released it, so you have to wait. Okay, moving on. It's a bit confusing, but if you read it thoroughly, then you'll understand. So display Y and Z. Now Y is unlocked here. Y is unlocked. So both have removed the lock on Y, both T2 and T11. Z is also unlocked. Now T1 has access to everything now. Okay, so T1 can read it, T1 can write, perform write operation, read it, add it, do whatever you want to do. Everything is unlocked. So go ahead and do whatever you want to do, basically. Okay. So Sumaya, is it clear or do you have any confusion?
It's clear.
Okay, awesome. So we did this. So do you want to read it before we recap, or are you comfortable? You want to read it once?
No.
Okay. So tell me what types of locking are there?
Binary mode lock and multiple mode lock.
How many types does multiple have?
Multiple mode lock has shared lock and exclusive lock.
Okay, so what happens in binary lock?
Um, Binary lock has two states, locked and unlocked, and
Uh-huh.
uh, uh, and all the locks are placed. Uh, all the locks are placed in one go,
Yeah,
and they're unlocked at the end.
correct. That's the key thing. That's the key thing to remember basically. Is that all the locks will happen at the start and all the locks will be released at the end. Even though you have finished performing an operation on one of the data item, but you can't release it until the end. So if somebody else tries to come and tries to grab hold of that lock, you can't do that unless it's released. Okay, so this is your example for that. Okay, and then tell me what's multiple mode. In multiple mode, tell me the what is called a shared lock or read lock.
There's the shared lock that is placed on an item when the transaction wants to read it. So multiple transactions can place shared locks on one item.
Okay, okay. Let's say I'll give you a scenario. Let's say that transaction one and transaction two place a lock on an item. Okay. Transaction one has finished its execution and releases that shared lock, but transaction two is still performing operation. It has not released the shared lock on that item. If there's a third transaction that comes in and wants to get access to the lock, it wants to basically put an exclusive lock on that. Can it do that?
No, because there's a
Can
shared lock on it.
Okay. Can it put a shared lock on it?
Yes.
Okay, good. You're clear on that. Good. And what is an exclusive lock?
An exclusive lock is used when the transaction wants to modify the item. So when an exclusive lock is placed, you cannot place another exclusive lock or a shared lock on it. And an exclusive lock cannot be placed on an item that has a shared lock.
Correct. Okay, I'll just recap this. Binary locking mechanism has two states, locked and or unlocked. When you obtain all the locks at the beginning of the transaction, release them at the end, ensures that transactions are executed with no concurrency related problem. Multiple mode locks has two locks, shared lock, which is read-only lock. With shared lock, the data item can be shared between transactions. This is because you'll never have the permission to update on the data item. For example, consider a case when two transactions are reading the account balance of a person. Database will let them read by placing a shared lock. However, if the transaction wants to update the account's balance, shared lock will prevent it unless the reading process is over. So, to sum it up, multiple transactions can place a shared lock on the same item, but they're only allowed to read it. And if a transaction wants to put an exclusive lock, it cannot do that until all the transaction who are sharing a lock have released that lock. Even if one of the transaction is still working on it with a shared lock, we can't put an exclusive lock on that. They should have put that here, but kind of put it here. So exclusive lock with exclusive a data item can be read as well as written. This is exclusive, can't be held concurrently on the same item. X law is requested by X lock X transaction. Transaction may unlock the data item after finishing the operation. For example, you can allow transaction by placing X log on the rest. Okay. I think we should put that information here. Oh, you can't go smaller than that. uh, okay, let's leave it then. Moving on. Okay, so it's 7. I think we should pause here and then start tomorrow because I'm sure, or let's continue as soon for another 5 minutes and then we'll stop. So
Okay.
For another 5 minutes, I'm going to first underline this so we know where to start from tomorrow. Uh, let's go back quickly and recap from there because otherwise we may forget. So I'm not gonna ask you to read it. Like I'm just gonna read it here because we don't have less time. We want to cover more of them to get it fresh in our head. So, need advantages of database management system: ease of accessing the data. Different files are created for each user, which they can access. It removes the redundancy by granting access to the users and decides how many parts of data is accessible to them by the database. So, ease of accessing, which means in file system, different files are created for each user, but in DBMS, it decides what part and how many parts of data is accessible by the user by granting them the access. Storage and management of data. Unlike file system, data can be directly stored in form of objects, which makes it easy to query. Avoiding duplicates and redundancy. In file system, storage of data might happen multiple times. However, we use data normalization in DBMS to avoid duplicate data. Concurrent data accessing. Multiple users can access data simultaneously through different applications. And database integrity means the data should be accurate and consistent by enforcing checks or constraint on the data. Three-level database architecture: you have internal level, conceptual level, and external level. This architecture was designed. Okay, so we have to stop because prayer is going on, and we'll continue tomorrow. We'll probably start with repeating this, guys, and then moving on to the new one. Okay.
Okay.
Okay. Sumaya, I've given you some tasks. See if you can action some of those if you have time on
Yeah.
the 208.
Yeah.
Right. Okay. Then. Bye bye.
Bye.